Hi everyone, I hope you all are doing great. In today's video, we are going to discuss about our next part, that is electronic structure and periodic law. In this section, we are going to discuss some basic definitions. Prior to this, we are going to discuss about why we are studying the arrangement of the atoms further. As we know that in previous video, we are going to know about that atom is the smallest unit which is not further subdivided. So that's why whenever we form any kind of chemical bonds or something, there is a always involvement of electron exchange, and we find out that this create a little bit of curiosity among us how these kind of atoms, how these kind of electrons are arranged within atoms. So we are going to get knowledge about it. Firstly, before directly jump into the orbital or suborbital subshell part, we are going to describe some kind of definitions. What is periodic law? In order to define the elemental properties, we are going to know about the how the elements are getting arranged in the periodic table. Basically, these elements are arranged in periodic table with increasing atomic number by as there are several kind of laws developed. Ultimately, we prefer modern periodic table where the elements are arranged in increasing order of their atomic number. So the periodic law means the statement about the behavior of elements when they are arranged in a specific order. Whenever you arranged elements in specific row or a specific column, they have some kind of similar properties. That's why we studied them collectively. In its present form, it is stated as elements with a similar chemical properties occur at a regular interval when the elements are arranged in order of increasing atomic numbers, as I described you earlier. Group of basically in periodic table, what we see that the hydrogen, lithium, sodium, potassium, rubidium on the extreme left side, the vertical columns elements are known as in a group, and whenever we see the elements in a row, that is hydrogen and helium, they are belong to same row. That's why they are arranged in a same period. So in this manner, we have 7 period with us and 18 columns where all the elements are arranged in the modern periodic table. Now next, moving towards the electronic arrangement, which is the actual parts of discussion. In electronic arrangement, we firstly in 1913 Bohr predict the electronic arrangement. That means prior to that, Thomson model will be comes into existence, where he is not able to fully explain the existence or the positioning of electrons in that atom. So the later on we accept the theory of Bohr, which is given by Bohr in 1913. He explained that the electrons are never lose their energies or never gain their energy until or unless they move or their original orbital. Like as if I want to say that if the electron is going to move in this manner, look at the marker here. If the this is a lower shell and this is a upper shell, if the electron is moving from this part to this part, then it will going to gain some energy and moving to that part. If you want to return back this electron, as I show you, if you want to come back it to the lower level, then it will release energy before coming to this position. In this manner, if this electron is remain in this original orbital, he never lose or radiate any kind of energy. But if it moves to higher level or comes to lower level, then it definitely lose or gain energy. Moving to next, the definitions. Firstly, this is shell. The location of and energy of an electron around a nucleus, that is designated by a value of n. Simplify if we look at the diagram. Here we see that this is a nucleus. Around that, this is a first shell. N is equals to 1 or a K shell. This is given designation given by the researchers at that time. Basically, nucleus very next to nucleus, that level is n is equals to 1. Next to that, n is equals to 2, n is equals to 3, and n is equals to 4. The alphabet will be moving in that manner, k, l, m, n, or so on. These are called shell. Within that shell, there are further subdivided shells. That is, look at this. This is n1. This can't be is equals to n minus 1 subshell. So 1 minus 1 is equals to 0. That means this level is not subdivided. Look at this. N is equals to 2. 2 minus 1. That means one more subshell. That's why it has two subshell, right? And n is equals to 3. There are further subdivided into three shells, S, P, or D. We will these designations are designated by the letter S, P, D, F, so on. Atomic orbital is volume of space around atomic nuclei in which electron of the same energy move, or these kind of shapes we discuss in the next video. For that moment, I use this book as a reference. Thank you so much.